Hello everybody and welcome back to my next tutorial. In this episode what we're going to be going over is a IK system for the feet. So this is one that I've made already. As you can see that it's working pretty well. There are some things that I could tweak, but this is just so you guys can go ahead and do it for your own models and your own games. It works quite well though, and if I just go off the edge here a little bit, you can see that it doesn't do what it's supposed to. It's struggling a little bit on the edges, but that's what's supposed to happen. The foot's planted and this one's just sunk down, and the pelvis has sunken down to an appropriate level. It's not fully squatted down, but again, you guys can tweak that later on. Now I've got a fresh project here that has not got any IK at all loaded for it. So if I just go over the edge, the legs should just hover here, and there's nothing that happening to it. So how do we get IK working with the Unreal Mannequin or whatever model that you've got? I'm going to be working with the Unreal Mannequin default because I know that's what everyone will have, and you can alter this logic for your own models if you so need it. Once this is finally loaded up, I think it might help if I close down the other window. There we go. So what is IK? IK is taking a bone and translating it in such a way that it gets the hierarchy of the bones above it and rotates and translates them as well, so that that bone that you're originally moving can get to the position that you want it to get. It's a lot more complicated behind the scenes, but that's the gist of what we're doing. And you just saw that with the stairs and the pelvis bone, with it moving down to accommodate the needs of the foot. So first thing I want you to do is go to your event graph. You should see this when you're using the third person character blueprint. So you're going to right click, and you're going to type in event. Okay, it might just be easier to drop down add event initialize animation. Since the initialization only happens once, this is the perfect place to put our cast to the third person character blueprint, or whatever your character blueprint's called. Now we can't get the player character for the wildcard in the animation blueprint. What we're going to do is try get pawn owner, and as the third person character we're going to set this to a new variable. I'm going to call mine player ref. We need this for two functions that we're going to make. The first one is going to be a way to get the right position for our foot to go to. To do this, we're going to do a trace ground, or ground trace or whatever, I don't really mind. It doesn't really matter the name of the function, it just matters what's actually inside of it. We're going to do a line trace. If you're coming from other 3D software into Unreal, you might already know this, but a line trace is basically, in other computing terms, is a raycast. It fires an array from one vector to another and returns anything that it hits in between that. Normally it returns the first thing that it hits. So the starting vector and the ending vector are both going to be parameters, and we can just add them in like that. You can draw the debug if you want to see it actually in action. I'm not going to do that. On the out hit, right click and split it. The location, drag it out and break it again. Now this is where we need the player reference. We need to get it. We need to get the mesh location, and we need the Z from this. So break it, and we need to compare these two by taking one away from the other. Add in a return node, return this float here. So there. What we should probably do is from this return boolean, we should probably hook that up into a branch, and only if it does hit something should we return something. Just a little precaution to take. Okay, now that we've got that, let's make the function that will actually set the foot IK. So foot IK, this is going to start us off with a branch. And the condition is going to be this pre-made one here. I didn't make this one, this should come already with your third-person character blueprint. If it's not, or if you're using something else, then try get form owner. You want the movement component. And from here, you want to get his falling. And this is essentially the same as this. But since it's pre-made, I don't want to complicate things further. I think it's already being set here. So exactly the same procedure, just in the main animation loop. So anyway, if it's falling or if it's in the air, then we don't want any IK to occur. So what we do is, oh wait, we haven't actually set up the IK system itself. Let's go and do that. So, animation graph, you should see this. What we want to do is, over here, we want 2 bone IK nodes and a transform modify bone node. So, since this is incompatible with the 2 bone IK, we need to not drag off of it, we need to right click elsewhere on the graph. 2 bone IK function. No, not that one. 2 bone IK, and we want the skeletal nodes, skeletal control nodes version of it. So if we drag this into here, it'll do the conversion for us. And what we want is to right click on this effector location, split it, and we want the X. Bring this up here, promote it to a variable. I'm going to call mine left foot IK. Now, if you left click on it, go to IK bone, we want the left foot, so go down to what you called your left foot. If it's the mannequin like I'm using, it should be foot underscore L. You want to change the effector location space to bone space, and the effector target to the foot. That's on the same bone here. And the joint target to the bone space, and the joint target to the calf. Now, if we just duplicate this by Control W and bring this into here, the joint target location for the left foot is 50 and minus 10, and for the right foot, which is what this one is, it's going to be minus 50 and minus 10. So we just change these over to the right calf, the right foot, and the right foot. No, not the right, all the right foot, there we go. Okay, now the effector X location, we're going to promote this to a variable as well, and call it right foot IK. And we want to times this by -1. Okay, we're nearly there with this whole setup. We just need one more node, so drag off here and type in transform modify bone, this one here, and drag this final animation pose result into here, and it'll convert it back into an usable pose. Now the translation, I'm just going to move that over there. Left click on the node, come over here to bone to modify, and click on pelvis. And the last thing in here is the translation mode we need to add to existing. Right click on the translation, split it, and we only care about the Z. Bring that up, promote that to a variable. I'm going to call mine body fix. think that's all the setup in here that we need. Just double checking, because I've done this tutorial a few times now and I always seem to miss something. But I think this is good. Let's go back to the foot IK. Now we want to smoothly transition each of these values to 0 if it's falling. So to do that, let's start with the left foot, set it. If you watched my camera controllers tutorial yesterday, or some point, you might have seen me use something called an F interp or a float interp too, which is what we're going to be using a lot today. F interp 2, and return value into here. Now the current is going to just be our float. The target is going to be 0, delta time is going to get world delta seconds. Plug that into there, and the interpolation speed I'm just going to put to 15. And just repeat this for all of these ones here. This is probably one of the most repetitive things that you have to do with this thing, but you get into the real cool stuff in a bit. And by cool, I mean overly complicated, but it works, so bear with me. Left into 2, and delta time is this one here. Current is here, and interpolation speed set that to 15, and we are done with this. Now we get to the real fun stuff. When it's not falling, IK, i.e. when it is falling, i.e. oh, sorry, it's a bit late. When it's not falling, i.e. when it's actually walking along and the floor's changing. So it could be stairs, it could be different types of terrain, it could be all sorts of stuff. I'm just waiting for the autosave to finish before I continue. There we go. Now, from the false, what we want is a sequence. A sequence is a type of flow control that does this pin first, and once this pin has fully been completed, then it does this pin, and then we can add in one more pin here, and it just keeps going. It does them all. They're very quite useful. So what we want to do is a trace ground, this pin, and another one for this pin. And this is where we're going to find the values required to do the IK stuff. I'm just going to drag that up here and drag these further down. That seems good. Now we're going to drag off here and we're going to make a vector. And do the same for here. I don't know why that randomly zoomed out so much. Highlight both, Control W, and hook them up to the second set. Right. This is where the player reference comes into its own, really. We're going to be doing a lot of stuff that requires this. Drag off of it and get mesh, socket, location. And you should see get socket location with the target being the mesh. I want to drag this over here, come on, there we go. And straighten the connection, just so it's a little bit easier for you guys to read. Now, we want two of these. One for the left foot, one for the right foot. Now if we split the value, now we are only interested with the X and Y positions for these sockets, so let's just sort that out now. So for this is going to be our left foot, this is going to be our right foot, so we need the X and Y into both of these, and this is going to be our right foot one. We'll sort the socket out in just a moment. There's a lot of clicking and dragging with this tutorial. Now, this is where the maths can get a bit complicated. Please make sure that you've got the nodes that I've got up precisely, otherwise this might not work as well as you'd hope. So capsule component, and from here we need two things. We need the half height and we need the location in world space, not local space or relative space, world space. And we want to split this, and we're only interested in the z value. For the half height we need to drag off divide by 2, and we need to add this value back onto it. So add, I'm just going to control that into there and drag that into there. Now I wrote down the way that these are supposed to go, so add them together, and then this value minus this, and this and that value minus that. So, yeah, it's fine, I got it. I just want to make sure that this is right. I don't want to give you guys wrong information. Drag these back a little bit. So the z value minus the division is going to go into the starting values, the starting vectors here and here. This is also going to go minus into the plus, so the z value minus the addition that we made, and that's going into our end. So yeah, that's right. So what we need to do now is set the body fix variable using these two return values. So I'm going to set these as local variables, as we don't need them outside this function, and so there'll be no point in them being global. So this is going to be our left foot result, and this is going to be our right foot result. I'm trying to prevent spaghetti junction here, which is why I'm trying so hard to use variables and just sequences and stuff like this, just to make it as easy as possible to understand. And the second pin here, just drag it down here and set body fix. Double click on it to make a rewrite pin, just to make it a little bit easier to read. Now the body fix is going to require a few things. It's going to require the left foot result and the right foot result. We want to check if this is less than the other. And if it is, then we want a select float. And this is going to be the index for it. So the right foot goes into the false and the left foot goes into the true. This return value is going to go to a clamp, float, and we need the capsule half height, which is over here. Make a rewrite node, and what we need is it divided by 2, and that's going to go to our max. The minimum is going to be the capsule half height divided by 2 times -1 to get the minus value. Minus 1, and don't forget to times this, make this 2. This clamp is going to be finally fed into F_INTERT2 as the target, and the current as the current body fix. Delta time, get world delta seconds, and interpolation speed 15. And the return value goes into set body fix. We can drag this forward a little bit. So if we compile this, it should sync it when we go up the stairs, but no further than we can kind of see it. Anyway, it might be easier if I just print out the body fix. I'm not actually calling the function, that's why. I was talking about it. I was talking rubbish when I said that you can kind of see it. Sorry. Make sure it is actually working before you test it. So -1, and then when you go up the stairs, -19, -20, and then, so yeah, it is working. So, go back to the foot IK. We can get rid of this because we know it's working, and we need a branch after this. The condition is going to be the same one that drove the select, which is all the way back here. On true, we want to choose the right foot to set the IK to. So set right foot IK, and well, we need some similar maths here. So body fix, and we need the absolute value. From this, we need to add on the result from that raycast or line trace. So local variables, right foot result, drag it into there. This needs to go into an finterp 2. The return value goes into here. This goes into the target. Current is the current right foot IK, and we can get a world delta seconds. I know it's bad practice, but at this moment I just want to get things to work and then make things efficient. You guys can all just get a single get world delta seconds in this function and just have everything referenced to it. I'm just trying to make things as neat as possible for you guys so you can look at your event graph and compare it to mine a lot easier. It'd be a lot harder to do that if it was Spaghetti Junction. So yeah. We also need down here to add this for our left foot result, because we are setting our left foot IK down here to using a similar method to above, using an finterp 2, with this as the target, left foot IK as the current, delta times seconds, as that, and 15 as that, and don't forget to hook up the return value to that set. Now we need to set the inverse of this, so left foot set, and finterp 2. This one's going to be a bit easier because we don't need a target, the target is 0. The current we can get from back here, delta seconds we can get from here. Finterp speed is going to be 15. We are very nearly there, guys, don't worry. Set the right foot IK on the bottom rung, and set again finterp 2. Current is from up here, delta seconds here, and finterp speed there, return value hooked up to the right foot IK. This should now work, hopefully. Keyword there is should. Play it. And it's not doing it. Or is it? I know why it's not working. I've missed a step, I do apologise. We haven't actually set the socket locations because you guys haven't actually set your socket yet. For when I was testing it, I've already made my socket. So I've made 2 sockets, one on each of the foot. So if I click on the left foot and right click, add socket, I've made mine as close to the center of the foot as I could. The coordinates are here if you're wanting to copy them from the mannequin. This is for the left foot, so -13, 8 and -1 and on the foot on the right it's each value times by -1, so 13, -8 and 1. And if I go to here, remember the top one's the left foot, so I'll socket. It is case sensitive, so be wary of that. Foot_R socket. Go back to here, and this should now work, which it does. And there you go. That's how you do a very simple, well, I say simple for IK system in Unreal. So I hope you guys enjoyed this. This was a subscriber request, so thank you for that. If you've got any other suggestions for future videos, do please leave them down below. Please do check out my Discord as well. I do try to post there whenever I've got an update on a video. You can also give me some suggestions. We've got a help channel as well, so if you guys need help with your blueprints and you just don't know what's going on with it, then just send a screenshot into that channel and I'll have a look. You guys are welcome to give each other help as well. We're trying to build a nice little community here. Anyway, I'm just really happy that I finally got this working out. You have no idea how many times I've tried to record this tutorial, each time with something going wrong. So don't be too worried if your IK system doesn't quite work. Just look through the video very carefully. You'll get there. I mean, it took me about 2 hours the first time to try and get things to work. So 20-minute tutorial surely shouldn't be that much in comparison. Anyway, hope you guys enjoyed. Please do leave any comments down below, and I'll see you guys in the next episode. Goodbye.